also there. I can see your screen.
Okay, okay, thank you. Then I'll start.
Okay, ma'am. You can go ahead, ma'am.
Okay. So I'm Arulselvi, training officer and principal of NSTI Women Trichy. I have worked for last 22 years in electronics branch in various institutes like NSTI Women Trivandrum, NSTI Chennai, NSTI Indore, and presently working at NSTI Trichy as principal. So in my experience, I have handled classes on microprocessor and microcontrollers, industrial automation with PLCs and drives, power electronics and industrial applications, and maintenance of power electronic equipments, and so on. And presently at NSTI Women Tiruchi, we are conducting courses on smart city, IoT technician smart city. And there I'm also involved in doing the projects on smart city applications. As we all know that very shortly in another 5 to 10 years, India is going to have many smart cities. And let us start PLC, about the PLC. PLC is programmable logic controller, which is an industrial computer. Which is an industrial computer. It monitors inputs, makes decisions based on its program, and controls the output to automate a process or machine. I hope that you all have worked with a microprocessor based system, and you would have heard of automation, small automation or a big automation. Automation can be done with microprocessor, microcontrollers, with embedded controllers, as well as PLCs. So PLC is one such controller, which is very suitable for using in the industries for small scale automation as well as large scale automation. So today we'll just see an introduction to the PLC and how to do simple programs with PLC and the applications. Okay. So about the PLC, the automation of many different processes can be done, such as machines or factory assembly lines, is done through the use of the PLCs. And about the PLC, it was introduced in 1960s. First commercial and successful PLC was designed and developed by Modicon. Dick Morley was considered the father of PLC. Earlier, it was a machine with thousands of relays and contactors. That is what I mean to say is, before the invention of microprocessor, microcontrollers, we were using relays and contactors, and PLC was in the basic form, and with electrical devices, they were able to do small level of automation, and that is what it was going on initial period. And later on, after 1970s, once the microprocessor was devised, a better automation we could do with the help of PLC, because PLC is having a microprocessor inside. Okay. And what is microprocessor? There is no automation without a microprocessor. As you all know, your phone is having a microcontroller with lot many applications: audio, video, imaging, image processing, and memory and communication, and lot many operations you could do with phone. So everybody must be knowing about the microcontrollers and its applications. But the significance of PLC, what I can say is, PLC is very much suitable for 24 hours, and throughout the year you can use the system. It is a rugged system. It is not just like any small processor. It is suitable for industries, which means throughout the day, 24 hours an industry will be operated, and throughout the year you can operate it at variable temperature and pressure and humidity. You can operate the PLC. So PLC is such a rugged system. So it is preferred, still preferred in all many industries, refineries, petrochemical industries, and so on. So what such a PLC is having a processor, an input module, output module, programming device, and naturally a power supply to power the system. Is it not? So what is input module and output module? Input module is the section of the PLC to which you will connect the input devices. Actually, for example, you want to operate a small automation with the sensors and switches, push buttons. Say you want to operate a motor also, then you'll have to connect the switches and sensors to the PLC. So the input module is the input section to which you will connect the sensors, push button, contact, limit switches, and so on. Any type of switches, everything you can connect to the input module, and you can operate it. So by operating the input module, what happens? The status of the input will be transferred to the processor. And what is the processor work? What is the role of the processor in a PLC? And where do you write the program? You can normally write the program in a computer or laptop and transfer the program into the PLC memory. Okay, so that is called the programming device. The programming device can be a laptop or a desktop computer through which you can use programming language installed in the computer and write the program into the PLC memory. And what happens, how does the processor work? Once the input devices are operated, the processor will read the inputs, will understand what to do with the inputs, and then execute the program. Whatever sequence of operations you want, that will be executed by the processor. So execution means what? The program will be executed, and whatever necessary corresponding outputs are to be transferred to the output module will be done, which means outputs will be updated frequently while executing the program. So this is the regular process of the PLC. Okay, so every fraction of second, you can assume every fraction of second it will be checking the input modules status and executing your program and updating your outputs. So this is what happens in a PLC. Like even in a human being, with a human being, say a mosquito is biting you, what you will do? The mosquito is biting, you will sense it, and that is an input to the brain. You will, the execution of the brain is, it will ask you to hit the mosquito, you will hit it. And then again come back to your normal procedure, next action. You will try to start the next action. So this is what happens in this PLC also. Every step by step, the operations will be performed. Your program will be executed step by step in a sequential manner. So the PLC is meant for small program also you can execute. A large program, a large automation program also can be executed with a PLC. So let's go to the next slide. And power supply, as usual, without power supply, there is no automation, there is nothing, there is no process. Okay, so power supply is the main and foremost. A regulated power supply is the first essential thing of a PLC, item of a PLC. Let's go to the next slide. So there's such a power supply. Why do we need power supply? For powering the microprocessor, input module, output module, and for powering the sensors, limit switches, your output relay, everything you need a power supply, is it not? So what we can use 24 volt power supply or 120 volt. Okay, so these two mandatory in any PLC. It will have provision for 24 volt DC as well as 120 volt AC. And let's go to the next one. We'll just see what is CPU. The CPU consists of the following blocks. What is there inside the CPU? Everyone must be knowing by this time. It comprises of arithmetic logic unit for doing mathematical operations and logical operations, and it comprises of timers, counters, flags, and it can be used for scanning the inputs and executing the output, executing the program. And it will have, the CPU must be having communication link with the inputs and outputs and data. And what is the next role of the CPU apart, like behind the process, internally the CPU always keeps on doing self diagnostics. Okay, always maybe every half an hour once it will be checking itself whether all the modules are working, input modules are working, output modules are working, and power is there, any communication interruption is there. So all these things, it will always be checking it by itself frequently. So a diagnostic program also will be running behind parallelly. Okay, so that is called the self-diagnostics. That is also an important component of the PLC functioning. So next, we have seen the input and output modules. And the programming device you could see here. Programming device, I said, it can be a computer, laptop, or a HMI. Now, major components of PLC. In the previous figure, you have seen only the symbols, symbolic form, and the name you have seen. Here you can see the devices, input devices like start button, stop button, sensor, proximity sensor, any type of sensor, optical sensor also. If a bottle is moving, you need to sense the presence and absence of the sensor. So that is called optical sensor. You need to use an optical sensor. Okay. And if a metal object is moving, you have to check whether it is the metal is, you can, with an induction type of sensor, that is a proximity sensor, you can check the presence and absence of a metal or metallic object, for which you need a proximity sensors. So similarly, there are so many type of sensor. Okay, depending on the parameter you are using, there are so many types of sensor. We are seeing only samples. So limit switch. The limit switch, I can tell you, for example, lift is moving from ground floor to first floor. Okay. So how do you understand that the lift carriage has moved to the first floor? To have a limit switch. So at every floor, you will have a limit switch. Okay. So then only you can understand that first floor position has reached, or second floor has reached, or ground floor has reached. So you need to set every floor. So you can either have a very good sensor or a limit switcher. It is suitable for big structures. Limit switch is suitable for good big structures where movement is going on and where you have to sense the movement. Okay. And so these are some of the examples of the input. And the PLC, industrial type of PLC, you could see how it is looking like. So with a PLC, maybe 4 input and 4 output, you can have PLCs, or 16 input, 16 output, 64 input, 64 output, or hundreds of inputs and hundreds of outputs. Also, we are having PLCs. So it all depends on what you must be knowing. You must have understood by this time. Maybe for a small automation, you can have a small PLC. For a big level, like a milk product processing system. Can you understand milk processing? Daily we get milk packets, milk products, curd, everything daily we are getting from the dairy processing industry only, is it not? So there, imagine maybe like 30,000 liters of milk is being processed every year, every hour. In 1 hour, 30,000 liters of milk is being processed and packaged. So in such an industry, imagine the role of a PLC. Okay, it should be reliable. The PLC cannot stop in between. 24 hours of operation should be there, and the PLC should be such a reliable device. It cannot hang in between. Okay, it should not hang. It should execute continuously 24 hours daily. Okay, so PLC is such a system. You can imagine by this time. Now, this is the center portion is the PLC. A small PLC is shown. And output side, you can see what all can be operated. You can connect a bulb, indicator bulb, on, process off, or alarm indication bulb, or you can operate through a relay. You can operate a motor, a small motor or big motor. You can operate a door with a motor. You can operate a big conveyor belt with a motor. Okay, so like that you can use you can do many industrial operations, field devices. You can use a heater or furnace, okay, with the output module. So anything can act as an output. For a PLC, any operation, any field device of an industry can act as the output. But only one problem, only one constraint is there. You cannot connect a motor direct to the PLC. You cannot simply directly connect a motor to the PLC, or a big heater or a furnace. You cannot directly connect the wire to the PLC, because PLC is a digital system. PLC is operating with 5 volt only. Microprocessor generally works with 5 volt only. With 5 volt, you cannot operate a machine. So what we do, that is why we are using an output module. Okay, okay, children. So we are using an output module attached to the PLC, so that the 24 volt or 120 volt operated relays are connected, can be connected to the output module, and through the relays the motor or furnace or any field device can be connected. Okay, I hope let us see further. If any doubts are there, we'll see. And about the routine scanning work of the system, how the system regularly works. The PLC will check the input status. I've already told, like us only, like our brain, how it works. It will regularly check the input status, execute the program, and update the output. Okay, this is what happens in a PLC continuously 24 hours. It will be checking. You can start the process, you can stop the process, you can change the settings of the process. It will understand in milliseconds. It will come to know what changes you have made in the settings. Okay, so this is what happens. Most commonly used languages can be ladder logic, functional block diagram, sequential function chart, Boolean mnemonics. And very most commonly used is ladder logic, which is very simple. It is just like relay logic. It's just like relay circuit only. Okay. So I hope you know about the relays. Let me give a small introduction about the relay. So you can watch the relay diagram. I hope you could see this relay diagram. So this is the relay controlled motor. Okay, it's a, we are seeing a relay controlled motor. So in this, what we can see, a 12 volt supply is given to the relay. Okay, can you tell how many terminals are there in a relay and the types of relay? What are all the types of relay we generally use? Normally open, normally close. Is it not? We generally use normally open and normally closed relay. And here also in this example, a normally open relay is shown. And what is the main part of the relay? Parts of the relay. There is a coil. When you give supply to the relay coil, it will become an electromagnet. Okay. When you give supply to the relay coil, see, there is one supply, 12 volt supply is connected to the terminal, like NO contact 1, and you see the motor, one terminal is connected to the supply, but supply will not directly immediately go, only the supply will pass to the motor when the relay becomes an electromagnet, when the relay produces a contact. Okay, then only supply will go to the motor. So this is the main portion where when you give coil supply, the coil acts as an electromagnet and produces a magnetic field, and because of the field, this contact makes the contact between the power supply and the motor is made, that is the yellow color line shows that the power supply gets connected to the motor terminal when the relay makes a contact. When the relay will make a contact? When you give coil supply. Okay, coil will become electromagnet and establish connection, electric supply from the supply, 12 volt supply to the motor. If you give 230 volt also, it will go to the motor. Okay. So this is what happens in a relay, and this is how we are connecting the field devices. It may be a motor or a bulb or any dryer or any fan or fan motor or heater or furnace, a welding machine, electrode of a welding machine. So for any industrial application, you can assume that the load is connected in this manner only with the help of PLC, okay, through a relay. I mean to say that relays and contactors are very largely used to establish the supply to the field devices. I hope you all are following. So let us go to the next thing. Now I'm showing the NO and NC contacts here. This is called the normally open contact. This is normally closed contact. So generally the input devices, that is a start button, a push button, or a toggle type of button, anything, it is indicated as a normally open switch. Okay, so a push button normally open, when you push it, it becomes closed, current will pass through it. Okay, and output, how to write, while writing a program for a process, a small process which is called a start stop process. A motor you want to start and stop using PLC. I am telling you how to write a program to do this program, to do this process. Okay, so input devices, a start button, a stop button. Okay, start button and stop button are X1 and X2. So X1 and X2 are the addresses of the, while programming we use X1 and X2 as the address. And what is this shown here? Coils. At the output side, we are seeing coils. Y. Y1 is the coil or relay coil of the motor. Okay. Anybody? Sanjay? Any doubts? I will give you phone, my WhatsApp number and mail ID. You can share. Okay, you can ask your questions. Chetan and Chandrasekhar. Chitra, how to? No, it's all right. I'll come back to you afterwards. Okay, so let us finish, and finally we'll have the discussion about the doubts and all. And now start button and stop button and motor is connected to the output. Okay, so this is how we write the program for connecting a motor through a relay coil. Okay, so now when you press the push button, start button, when you press it, what happens? There should be a supply which is flowing into the motor. How it flows, I'll tell. And now you just listen. Left hand side indicates the supply, 24 volt supply is available in this wire, and right extreme, this wire, what I'm showing, this terminal is connected to ground. Okay, so this is the terminal which is connected fully, continuously, 24 volt, and the right end is connected to the ground, so that supply always flows from the 24 volt to the ground. Okay, supply from higher potential to lower potential, it has to flow. So when you operate the 24 volt is waiting here, you operate the start button. Okay, and the stop button is already NC. Always we use stop button as NC button only. Okay, so that when you, if you want to stop, you can stop. Okay, normally default condition of the stop button is NC. It will be normally closed. Now you are starting the motor by operating the start button. Okay, once you start, the motor coil starts. It motor will be rotating in the field. The motor will be rotating. Okay, and what happens, the moment the motor goes into rotation, you want to hold the status. Okay, you want to hold it in the on condition. So you are using a contact of the output device, that is Y1, parallelly across the input, so that you will not disturb the motor at all. If we assume it's a conveyor belt, first if you give it the start button, then the conveyor will be continuously running till you stop it. Okay, so that way, in this program is sufficient for simply starting a conveyor belt. Now next thing, you want to stop, the operation is over and you want to stop. How will you stop it? That is an NCX2 is the stop button. By operating the switch, okay, this X2 is the stop button. Really in the field, you are having a stop button. Okay, this here I am showing only the program, how to write a ladder logic program I am showing you. So by operating this stop button, what happens, this normally closed switch becomes open and the supply is disconnected. Okay, the supply is disconnected and the supply of the motor stops. Supply going to the motor stops. Okay, so this is what happens in a start stop mechanism. This is how you operate a conveyor motor, and a conveyor belt is in process. Okay, so for this, let me try, I'll try to share one small image. A milk plant, you can see. You can see here how a process is going on. How an automation works in a big plant. Here, milk is going to be filled in the bottles, for which first bottles are manufactured. Bottles are manufactured and then the filling is going on one by one. Filling is going on and then capping will be done. See, orange color caps. Capping is going on. So this is how milk packing industry works. Okay. So just I wanted to show a sample how the industry packing, and see, sealing, labeling, all these things are going on. You can see that bottle is packed and everything is going in an order. Everything is going in an order, that is called conveyor. Okay, conveyor. With a single motor, you can operate a conveyor. So this is how a plant automation takes place with a PLC. Okay, this is HMI. All are being labeled, date seal is given, and see the label. Everything is done. Okay, automatically, everything automatic. Counting, finally packing and arranging inside the trolley. Little bit of human is manpower is required. Otherwise, you can do lakhs and lakhs of production per day. And lakhs, in a dairy, you may be knowing that curd, butter, milk powder, yogurt, cheese, flavored milk bottles, and many products are being made every day. Okay, so it is this is the conveyor we are talking about. Okay, conveyor and capping. So let us go into our. So next, what is called configuring a PLC. Next, let us see what is called configuring. How to configure? Configuring means what? You understand what PLC we are using. You are establishing connection between the computer and the PLC and the field devices. Okay. You are just establishing connections between your laptop or computer and the PLC. You will come to know how many inputs are there, how many outputs are there, and what is the mode of communication, how to establish connection. Okay, so these things we have to establish. Then only you can write the program on the computer and you can download your program into the PLC. Only after configuring the PLC with the help of computer, you can download your program or write your program into the PLC. Okay, so that is called PLC configuration. And what is this? Let us see. That is a timer. And there are there are plenty of functions what you can do with a PLC. We are just seeing few examples. That is assuming a small rotating a small table. Assume that some 5 bottles are rotating in a table. Okay, and there is a sensor. There is a sensor. When you operate a sensor, bottle filling takes place. Okay, you may know that you can assume that a small bottle takes less time to fill and a big bottle takes more time to fill. Okay, maybe 200 ml, 500 ml, 1 liter bottle, like that. So accordingly, once the bottle is sensed, you can start the filling, maybe 5 seconds or 10 seconds or 15 seconds. Okay, so for which you can design a timer. You can use a timer function of the PLC to fill a bottle. Okay, so depending on the size of the bottle. So for which, how will you control this timing? Timer is a function, and how it is being done. There is one solenoid valve. Okay, for it is like the device electromagnetic valve. Okay, so once the bottle comes near, you will operate the valve. The valve only is operated, solenoid valve. It will open. Okay, once the bottle comes near, valve will open and fillings takes place for 5 seconds or 10 seconds or 15 seconds, depending on the size of the bottle. And whatever is the size of the bottle, accordingly you have to change this preset value. Okay, so this preset value will be changed according to the size of the bottle. And once the filling is finished, the bottle is finished, then what happens? This bit here, this NO becomes NC, and then output is done. Uh, the filling starts. And here this example is, once the timing is over, the bottle filling will be over and the next bottle will come. So for which you have to rotate the table. For getting the next bottle for filling, you have to rotate the table. So this motor will be operated. Okay. So just assume that there is a rotating table with 5 bottles, and one by one filling of each bottle takes place, and the filling process needs 5 seconds delay. Okay, for that only this program has been written. This is the thing. So this is the figure what I was telling about. So a small conveyor belt filling is going on. The number 1, 2, 3, there are 3 sensors. Number one sensor senses that bottle has arrived. Number two fills the bottle for 5 seconds, and then the solenoid valve, that is top tap is there. No, the tap is nothing but electromagnetic tap. Okay, electromagnetic tap. Okay, so through which the solenoid valve, the bottle gets filled. And then once filling is over, then the motor will rotate, motor will move, motor will get operated. Then next bottle will come for filling, the previous bottle will come to the end, will come to the third sensor position, number 3 sensor position. So what happens, the person will understand, or the next one robo or something will come and pick this bottle. Okay, so like that we can write the sequential operation step by step, stage by stage. Okay. So there are different PLCs available, software available, and brands available. Siemens Simatic S7 is Siemens, Rockwell software, and TIA Portal is also from Siemens. And American brand, European and Japanese, all are available. Rockwell Automation, Allen Bradley, and General Electric, Texas Instrument, and Schneider are all American products. European is Siemens, Festo, and Japanese product like Toshiba, Omron, Mitsubishi. All these are available, and there are hundreds of models still. These are all very famous models of PLCs used in the industries. And areas of operation, we can see that packaging industries, PLCs are very largely used for. Just now we have seen a milk processing industry where packaging was there is a lot of work going on in a milk processing industry, like filtering, heating the milk, processing the milk, and filtering, removing the fat, the percentage. No, there are different packets of milk coming, green packet, orange, blue. So accordingly, the percentage of fat is being removed. So for that, again, they are having another machine. And again, packing separate, and bottle, in the form of bottle, it can be packed. And packing itself, we can, after making the manufacturing bottles only, they are packing the product, and then sealing it, capping it, labeling it, and the date, everything is being printed on every packet. So everything is automatic. Only finally removing the packets, removing the finished product, and distributing to the city and public is done by the manpower. Okay, so almost 80% of the automation industry is running with the PLC and its field devices. So now we are very much reliable. You know that, like car manufacturing organizations are there, factories, like so many things are there. Hyundai is there in Chennai, Hyundai manufacturing. There are so many car manufacturing factories where they make 200 to 300 cars being manufactured per day. So everything is done with the PLCs. Okay, and machine control, robots manufacturing. Okay, all these things are being done with food processing. Food processing industry, you can right from biscuits manufacturing, chocolate, dairy milk chocolates we are using, Kit Kat, like that. There are many things being automated. You see that even like a breakfast, those packets are being made automated in many countries. Okay, so food processing industry, like pickle manufacturing, ghee manufacturing, and chili powder, like that. Many food items are being processed. Everything is ready-made, ready to use, and sealed and packed form, so that we are saving time by using those items. Okay, so food processing industry is a new emerged industry where many people can get job, and we can also start a small food processing industry with the PLC once you learn PLC, it is not a great job to work in such a place. And material handling, that is packaging, lifting, and packing cargo, and in the shipyard and all, material handling, and in industries also. Okay, so material handling, we can use automation, like big cranes, automated cranes, robots, all these things are automated. Textile industries, printing industry, so all these places we can use. Advantages of PLC: replacing human operators, dangerous environments, beyond human capabilities. So, replacing the PLCs are maybe where hundreds and thousands of human were working. PLCs have reduced the human interference. Okay, so they have reduced the human operators, and the dangerous places wherever like very high temperature, wherever high temperature mold, like what to say, molds are made. Okay, automation can be employed wherever very high temperature or low pressure, such areas we can go for automation with the PLC. Dangerous environments, there we can go for machines with the PLC. Okay, so it is a gift. Flexibility in programming and reprogramming, that is nothing but if you have made one automation process and you want to make some changes, you want to add some more protective features, you want to make some more flexibility in the operation, user friendly, you want to make the automation user friendly. Okay, some devices or alarm devices have to be added. You can do it very easily within hours or minutes. You can do, you can correct the program, you can add one or two devices, because adding also just a simple work only with PLC. Okay, it is easy to work, cost effective for controlling complex systems, and improves productivity. Since it is an automated, it works with any number of devices, and many very big program also can be executed. It naturally improves productivity. It is very much helpful for increasing the production. Cars, they are telling 200 cars per day are being manufactured. Then imagine the speed of production, and small physical size, high speed of operation. Okay, it will work very, very quickly, because every instruction is being executed in milliseconds and microseconds. So naturally, a program can be executed very quickly and depending on the user requirement. Ability to communicate with computer systems in the plant. It is able to communicate with the computer system, communication network. And ease of maintenance, troubleshooting is possible, reduced space, energy saving, everything is possible. Yes, I could not hear. Sir, how to, I could not hear lower hand. Anybody wants to speak? Invite. Raise hand பண்ணது எனக்கு புரியல.
எங்க இருக்கு?
Okay, I'm not knowing. Sorry,
What?
I finished.
What?
They want to communicate. I'm not.
Even I don't know.
So I hope it was useful for all of you.
More. Raise hand.
PLC device. So I wish to, I hope you all have understood.
Let's face the class for today.
So I end up the session. Thank you.
Stop screen share for you. Now talk normally.
57 வந்துச்சு. வீடியோ ஆஃப் பண்ணு.
என்னாச்சு?
இல்லடி நிறைய பேர் கேக்குறாங்க பேசணும்ட்டு.